Okay, so it looks like it's recording now. Okay, hello everyone, and welcome to class 4 of 5. Um, and so today, so by the way, this is being recorded. I just wanted to let you know. And so today we are going to be doing the first part of the hands-on implementation of our program. Okay, and we're going to start by finishing yesterday's material, and that should only take maybe 10 minutes or so. Then we're going to go on to introducing the hands-on project that we'll be doing for the next 2 days. And so today we're going to be doing is importing the data, first of all, for our project, defining the necessary variables, and defining the necessary functions. Okay. So let's start by finishing yesterday's material. So it should come up right about now. Okay, cool. So let's go on to right here. So, so we basically ended last time on right here. So we were on like how to calculate the size and shape of an array. And so just to reiterate, in case you forgot, the size of an array is just how many elements you have in a certain array. The shape is just the dimensions, and you can calculate them using like these commands over here. Okay, and so you can access specific elements of an array, and we're going to be looking at how to do that. So first, we're going to access the entire rows and entire columns. Okay. So to access an entire row, if we have some array, my array, right, and we want to access the first row, we can put brackets and then 0, and that'll access the 0th index row, so row 0. And we can also access the first column by doing this right here. So bracket, colon, comma, 0, bracket. And what this does is it takes everything, so the colon just means take everything in, so take all the rows, okay? So take every single row that is there, and 0 means take the 0th column, okay? So take everything, every row, and take the 0th column, okay? And so an output of that would be just like right over here, okay? And you can look at more detail on this on your own in the slides, but I'm going to go kind of fast right now. And we can access specific elements as well by defining the row number and the column number, okay? So if we define, the row number to be 0, so second row and first column. So if you go to the second row and the first column, you get the element 12 in this example, and that's what it outputs. And so you can access specific elements. And now we're going to be looking at how to define special NumPy arrays, okay? So sometimes we want to fill an array, just like make an array with zeros, okay? So we can make an array of zeros by doing np.zeros, double parentheses, and then the dimensions. So if I do np.zeros, double parentheses, 5, 4, that'll make a two-dimensional matrix of dimensions 5, so 5 rows and 4 columns with basically just that many zeros. Okay, so it basically makes a 5-row, 4-column matrix full of zeros. And similarly, you can do the same thing for 1. So instead of zeros, you put 1s over here, and you define the dimensions, and you get a matrix of 1s. Okay, and you can also make the identity matrix. So in some if you have an identity matrix with n by n dimensions, you can just do np.identity open parentheses and then n, okay? And so this will print an identity matrix, okay? Yeah, so that was pretty basic stuff. Now we're going to go on to like computing statistics of an array. And sometimes in an array, we want to like take maybe the mean or the maximum or the minimum of the elements, right? We want to do some sort of statistics, right? So we can print out these statistics by just doing the array name. Oh, is there a question in the chat? Let me see. Do the dots after the 0 or the 1 mean anything? Oh, in the I think you're talking about the 0 matrix, or are you talking about this guy right here? The dots after this right here?
Yeah.
Yeah. Okay.
Yeah.
Okay. So these are just like this is 1.0, right? So 1 is the same thing as 1.0, right? So these right here are just decimal points. So nothing too fancy. This is just 1. But if you had like if you put an array of integers, then I think over here you would see that since these are actually integers and these are not considered to be floats, then there will be no decimal point after that. But these are like registered as floats, and that's why you have decimal points. Does that answer your question? Yeah, okay. Yeah, so we were on the statistics of an array. So we can say the array name dot some statistics. So for example, you can take the maximum, minimum, mean, standard deviation, and sum, and then you can put open parentheses. And that's about it. You just calculate the those statistics, okay? And so last time I asked you to like find out how to do a transpose of an array. So you should have done that for homework. But if you don't know how to transpose an array, you should be able to just do myArray.t, so dot capital T. So if you have an array called myArray, and you do dot capital T, it'll just transpose that array, just like in this example over here. Okay, just switches the rows with the columns. Okay, nothing too complicated there. And so now we're going to be going on to Matplotlib. So Matplotlib is a tool that we use to plot when we are done with machine learning. We want to plot sometimes, right? So we want to plot our results. So we can plot with Matplotlib. And so if we had an array of x values, and we had an array of y values, we can plot x by y. And what that does is it basically, if we have x values as 1, 2, 3, 4, 5, and the y values are 2, 4, 6, 8, 10, then basically the program will take 1 and 2, and basically it'll plot the point 1, comma 2. Okay? Then it'll plot the point 2, comma 4. Then it'll plot the point 3, comma 6. Then 4, comma 8, and then 5, comma 10. Right? And then it'll connect. So you can say plt.plot x, comma y. And then it'll plot all of those points and connect a line through them, through each one of those points consecutively. Okay. And then in the end, you have to show your plot, otherwise you won't see anything. Okay. And now we're going to look at how to basically there was a line in the middle, right? So if we want to plot the distinct points, we can just do plot x, comma y, comma lowercase o. Okay, and that just plots like these individual points. Okay. We can also shift the view of our like what we're looking at. So by defining the start coordinate, the end the start x coordinate, the end x coordinate, the start y coordinate, and the end y coordinate, which will define our new frame or frame of view. Okay, and so we'll define plt.axis. So basically plt.axis allows us to do this, and then you just in parentheses you put the first number, and then you put this you put the first x coordinate, so the left hand side, left bound, and then you put the right bound, which is a number, right, on the x-axis. Then you put the lower bound, and then you put the higher bound, and those are all numbers, right? So this should be 4 numbers right here. Then you show your plot, and that should zoom in. Okay. And so we can title our graph. Sometimes we want to be like kind of organized. So we can title our graph by doing plt.title, and we can put in quotes whatever title we want, right? And we can also do plt.x label some x-axis name, right? plt.y label some y-axis name. And this is what we get. So the title of the graph, x-axis label, y-axis label. Okay. So in conclusion, these are all sort of the tools you need to apply machine learning. So once you know the theory, this is what's going to be used to apply machine learning. Okay. And yeah, so you don't need to memorize everything that's over here. So if you forget like the syntax of something, you can just Google it and search up how to write it. But now you know that these kind of things exist, so you can always look them up when you need them. Okay. So we basically learned the basics of Python, then NumPy arrays, then plotting with Matplotlib, and all of those things. And yeah, so you should have done this homework yesterday. And now we are going to be going on to the hands-on implementation, the first part of the hands-on implementation. Okay. Before that, I want to ask if anybody has questions. Can you plot one line over another, or open? Yeah. So basically, if you every time you do plt.show, so if you remember the command plt.show, that just basically takes everything that you've plotted, right, and then it puts it into an actual plot. Okay, and then after plt.plot, or sorry, plt.show, if you plot something else, it won't show unless you show it again. And if you show it again, then yeah, so if you show it again, if you plot something else and show it again, then it'll plot on a separate graph, okay? And if you plot multiple things before showing, then it'll just plot them over each other on the same graph. Does that help you? Okay. So the uses for Matplotlib are like if you want to, so for example, if you have some data, right, and it's in a graph sort of format, and so you can graph your data, and then if you fit a model, as we will kind of see tomorrow, if you plot your like hypothesis and then you plot like the actual data, then you can see how visually how like far you are, and that helps communicate your results, because when you communicate your results, you don't really want to show other people a Python script, and that's not very like a very nice thing to show. It's very, very technical. And yeah, so Matplotlib is just used for like communicating your results. So does that answer your question? Okay. And we're gonna move on to the hands-on implementation, the first part of the hands-on implementation. Okay. So we're gonna first be introducing the hands-on project, then importing the data, defining the variables, defining the cost function, and defining the gradient function. Okay. So a lot of this stuff, for example, like the cost function, the gradient function, those were things that we talked about in the first class, but we didn't actually like learn how to implement it in actual coding language. So we're going to be doing that today. And then tomorrow we're going to be putting all of these things together, like the cost function and the gradient, in order to do gradient descent. So as you may recall, a few of the steps in gradient descent are computing the cost function and adjusting your theta values according to the gradient. So we're going to be putting that together tomorrow. But just for now, we're going to be setting ourselves up for that. Okay, so the first step to all of this, right, we're going to be coding, right? So the first step is to make a Google Colab notebook, okay? And I will give you this link. So you have to go to collab.research.google.com, and I will give you the link to that. So let me give you the link to that in the chat. So if you go here, and I will go there as well. So right here, I'll go to this link right here. So you'll see like a couple of things over here if you've ever used Collab before. If you haven't, then it'll probably be just one or two things here. And what you would do is you would go down here, so in the bottom right-hand corner, and you would click New Notebook, okay? So that's what I want you to do. I want you to click New Notebook. and that'll pop up something new. Okay, and I just want to make sure, like, see if anybody has questions on that. So has everybody gone to the link? Can you like say yes in the chat if you've gone to the link? So okay, so you've gone to the link, and did you click new new notebook in the bottom right hand corner? Okay, sure. Okay, so does anybody not have the like the Google Colab open or the new notebook open? Because this will be really important. iPad. I would recommend a computer. Yeah. Um, I wait. Do you have an iPad right with you right now? Are you working on an iPad right now? Then I guess you could request desktop site. Yeah, I could. I'm gonna click it myself. I'm gonna click new notebook myself. You guys go ahead and click it. But so Srishti, can you like on your iPad? I believe there is a button which allows you to request desktop site, and that should help you to do that. Okay. Anybody else having problem? Wait, Srishti, if you have access to a computer, then I would strongly recommend that you uh, join on a computer, like go off of this call and join on the computer. Do you have access to a computer? Okay, so just hang up from this meeting and then go join on that computer. Okay, so in the meantime, I'm gonna just go over here and click new notebook. Okay, so once I click new notebook, this is gonna open up a whole new place where I can just start coding. Okay, and I can, for example, I can type print hello world. Okay, and that will print. If I run it by clicking that button over there, that will print hello world. Okay, so you can run whatever you want over here, but we're going to be running our hands-on implementation, right? Okay, and so one other link that I have to give to you, sorry, over here, is this link right here. So I'm going to copy this link and give it to you. And this right here is a pre-made version of the hands-on material that we're going to be talking about. Okay, so you can open that up, and I would recommend keeping a window to the side. And so this is what it would look like right here. So it has a full explanation and everything. So if it's not clear to you in any way, anything that I say is not clear to you, you can go over here and read it over here, or you can just ask me. But you can read everything over here. It has explanations and everything, as well as the code. And so we're going to be using this for reference, okay? And I'm going to be going through a step-by-step tutorial, like actually typing out stuff, right? But right here, once I finish a certain part, you can just take this right here, copy this, and then paste it into your document. Okay. Does that make sense? Like what I want you to do? Oh, it's working for you. Okay. Does that make sense? Like the copy and pasting thing. So you can use that for reference, and you can copy and paste from that. Like after I finish every section. Does that make sense? Cool. Okay. Okay. So I'm gonna go back here And so this is untitled right now. You can name it whatever you want. But let's go to the slides and let me put this over here. Let's go to the slides and see what we have to do. So before we get into any of the coding, we have to figure out what are we trying to do here. Okay. So the purpose of this hands-on project is to create a like a tangible example of the regression that we've been learning about all week. Okay. So the goal is to perform linear regression and polynomial regression on Apple stock market data. Okay, so we're going to be using the day number to predict the stock price. Okay, so the day number like day 1, day 2, day 3, all the way to day like maybe 50 or something. And then on the y-axis we have the stock price. So Apple stock price is around $200. So it's around $200, $220 ish, right? So that's what we're going to be doing. Okay. The first step to any machine learning a program or any program in general is to sort of come up with a strategy or an outline. Okay. And so our strategy is to first import the necessary libraries. So we're going to import NumPy because that's going to be helpful. Import Matplotlib and a couple of other libraries, right? And then we're going to import the data after that, right? So the data necessary for predicting, like, so for example, the Apple stock market data, we're going to import that data. Then we're going to define the X and Y values from the data set. Okay. And then we're going to define alpha, which is the learning rate. And then we're going to do this thing called normalization. Normalization is just scaling down the data. Okay. So we scale down all of the data, and so that it's very, very easy for the computer to compute, like do linear regression, do polynomial regression, because it's running thousands of iterations of very, very large numbers, like computing matrix multiplication. And we just want to make it easier for the computer, so we do normalization, okay, to avoid overflows and all that. And then we can define the cost function and gradient function, okay? So we define the cost function and gradient function. So we take in the x, y, and data, and then we output like the cost or the gradient, and so on. Okay. So we're going to be starting by importing libraries. We're going to import NumPy and Matplotlib. That was kind of obvious, right? And then we're going to import one more library. It's called Pandas. And Pandas is a library which we're going to be using for reading the data. Okay, we're going to be reading the data. Okay, through Pandas. Okay. So let's import those. And so this is pretty simple, pretty trivial. So we're going to first import NumPy. Import NumPy. And we're going to import NumPy as NP. And what this does is, instead of saying NumPy every single time we want to access NumPy, right, we can just say NP, and that's a shorter form. Similarly, like we can import Matplotlib, so matplotlib.pyplot, and then we can import this library as a shortened form of the name, so as PLT. So every time we refer to Matplotlib, we can just say PLT. Okay. We're going to also import Pandas as PD. So these are the shortened forms of the names. Okay. And we can check that we've imported this correctly by printing a maybe an array full of zeros, right? So np.zeros of dimensions maybe 20, 3. I don't know. So this is an array, NumPy array. So this is actually a correct. So good. So basically, this means we've imported NumPy. We could have also done similar like Matplotlib and Pandas exercises, but so we're pretty sure that we've imported it correctly, right? Okay. So now we can just add code up here, and that'll make a new section. Okay. And so now we're going to import the data. Okay. So I have a link for the data that we're going to be using. and I'll just give that link to you. So this URL right here contains the data from GitHub that I've uploaded. And if you go to that link, so I will go to that link too. Actually, I won't have to go to the link. You don't even have to go to the link. You can go to the link and you will find, here, you know what? Let me just go to the link. So this right here is the data. And this format of the data is called CSV. So CSV stands for comma separated values. So these commas right here, they are separating the values in our data set. Okay, and it's called CSV because of that. So in the first column, you have the date of the certain stock price, right? And then you have the open stock price, and this is what we're going to be using or predicting. And so we're going to be using this for our Y values. And then there's the high price, the low price, the close price, and these are all different versions of like how the price, like reflecting based on the price and how people buy it and stuff like that. And so we're going to be using the open price. Okay, we're going to try to predict the open price. Okay, so we have to first import this data, right? So we're going to say URL is equal to this URL right here, this URL. Okay, so we're gonna basically we're telling Python to go to this URL and get that data and store it in the form of URL. Okay. And now we're going to load, like we're going to basically store the data in a data file. So we're going to say data file is equal to, df stands for data file, equal to pd, which is pandas, dot read underscore CSV. So this is some pandas code where it reads the CSV file, and it has to go to URL. It has to go to URL and read the CSV file at the URL. Okay, and we can print the data file, print df, and see if we've uploaded it correctly. Yeah, so this right here is the same thing that we saw in the other right here, but it's different font, different size font, and there's a lot of dots here. And it's telling us that there are 253 rows and 7 columns. Okay, so that's a lot of data. So it can't print all of that data here, so it just prints a little bit of it. Okay. Okay. Does anybody have trouble importing the data? Can you say like yes if you imported the data? Okay, Milan, it's not working for you? It's not so okay, so it's not working for you. So did you I think maybe one place where you could have gotten wrong is you didn't put quotes around the URL. Did you put quotes around the URL? It's not letting you access that link. So it's basically showing an error. Maybe you don't have a GitHub account. It's probably because of that. It's working for you now? Okay. Yeah, so did you put, Abhinav, did you put quotes around your URL? Okay. Wait, when you run it within Collab, Google Collab, does it work? Like when you print df? It's working now? Okay. Does anybody have, like, it's not working for them? Yeah, so you want to like test your code regularly just to make sure that you don't have any errors. So yeah, so this right here, URL is equal to, in quotes, the URL, and then df is equal to pd.read CSV URL. It's not working for you. So did you put quotes around your URL? Okay. And did you do an underscore over here? Like, so it says pd.read, so pd.read underscore CSV, and then in parentheses URL. You did that? Okay, did you print the data file? Did you print df? So basically, wait, so try copying it and pasting from here. So like importing data. So try copying and pasting from here. So did you try that? Did you try copying and pasting the code? Yeah, so does it work now? So when you copy and pasted the code, did you print the data file? It gives a name error. Name error. So, well, like, can you unmute yourself and like tell me about the problem?
I did everything. Yeah, I did everything that you told me to do. It's not working.
Okay, so can you like read to me like what does the error say?
It says um error says name error. IPython input, and then it gives the code in module, and it's pointing at df equals pd.read.
Did you import pandas? Did you
Yeah, I
import?
did.
So are you doing this in Google Colab?
Yeah. But can I see the code again?
Yeah, sure.
Yeah, I did. I did everything. It's not working for
Wait,
me.
did you put an end quote like around URL?
Yeah, I did.
Um, did you put a
Should I like
dot?
share screen?
Yeah, sure. I'll stop sharing for a second. Wait 1 second. Let me.
Um,
Yeah. So can you share your screen? You're muted, by the way.
yeah, I shared.
Okay. Let me enlarge this screen. Um, URL. So try going to that URL.
Um,
No. Yeah.
yeah, it works.
Okay. And so pd.read import pandas is pd. Uh, name PD is not defined. Oh, you never ran the previous cell. You have to run both cells. So unless you run the first cell, it won't import pandas.
Oh,
You
so
understand what I'm saying? So you have to go to the previous cell and run that, and then run this. Or you can go to runtime and run all. So go to runtime, which is in the toolbar right there
here?
on the top. It says runtime.
Yeah, this.
Yeah. So just click run all, and so
Uh,
it should work now. Yeah.
yeah,
Okay.
thanks.
Yeah. Sure. Let me share my screen again. Okay, cool. So now that we know that we've imported the data, let's just delete that and add a new piece of code. And so now let's go back to our presentation. Okay, so now we've read the data using pandas library, and now we want to define the x and y values from the data set. So first we want to define the y values. The y values are the second column, okay, the second column of the data set. So what we're going to do is we're going to define y to be equal to datafile.iloc, and you should probably copy and paste this. I'm just going to write it out. Datafile.iloc. iloc just means sort of turn it into a NumPy array. So this is like a pandas data frame right now. So you have to turn it into a NumPy array so that we can do what we know how to do on this array. And then, so we're going to take the first 50 values from the column at index 1. That's what that corresponds to. Then we're going to basically take, this is some pandas just some pandas syntax. You don't really need to know what this means for now, but okay, yeah. So now if we print y, so I recommend just copying and pasting this from the link that I gave you earlier. And now when we print y, we should get the first, yeah, so these are the open stock prices, okay? From the first 50 days, okay? And so let me know in the chat if you are having any problems with that. But for now, I'll go on and define. So it says we'll define x later, but m is going to be the length of y, the number of data points. Remember, so we sometimes use this variable m, and it's the number of data points. So we're gonna just call it the length of y. Okay, I think someone has something in the chat, but m is the length of y. So m is equal to len of y, right? So basically, all this is saying is that if there are 50 stock prices over here, then m should be 50. Okay, that's a helpful variable. Let me see in the chat if there are any questions. The link is in the chat right here. So right over here. Okay. Okay, so I'm gonna go back here, and so m is one of the sort of helpful variables, and now we'll just clear that, and we will go back to our presentation. So now we have to define the x values. So the x values are going to be 1, 2, 3, 4, all the way. For every single y value, we have a corresponding x value. So what we're going to do is we're going to use a for loop. First, initialize our x values at 0. So np.zeros, and we're going to create a m by 1 matrix, right? Just a vector of length m, right? And so basically the same length as y, right? And then basically we're going to use a for loop for I in range m for every single element. So we're going to iterate through every single element. So we're going to say that xi is equal to xi plus 1, okay? And in the code, I believe it's plus equal, sorry. Yeah. So, sorry, I meant I plus 1. And what this does is essentially it iterates through every single component in X. Right now there's 0, right? And so now we're going to set each one to be equal to I plus 1. Okay, So this is I is gonna iterate through 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to m minus 1. And this is basically saying set the ith row to be equal to I plus 1. So the 0th row will be equal to 1, and the first row will be equal to 2, and so on. So if we print, if we print print x, then we should get just 1, 2, 3, 4, 5, 6, yeah, all the way to 49. Okay, and we can also print x comma y, and we actually that's more advanced, but yeah, so we're gonna go now back to our presentation, and so we've defined the y values, we've defined the x values and the m values, or m, and now we're going to define alpha, which is the learning rate. Before that, does anybody have any questions? Okay. Okay, I think nobody has any questions, but just tell me if you have any questions. But so we're going to define alpha now, which is the learning rate. And I've experimented with this, and I've found that 1.95 is a good place for alpha. 2 is very high, and it will cause your algorithm to diverge. And it can't be negative. So it'll be like 1.95, and you can experiment with different values, but let's just keep it at 1.95 for now. So let's define alpha to be equal to 1.95. Okay. Cool. Now we're going to do normalization. Okay, so normalization, remember, we have to scale down our problem for the computer to be able to do all of this computation hard work. So we're gonna use the mean of x and the range of x to normalize the x values. Okay, so what we're gonna do, I'm gonna just add another piece of code here. What we're gonna do is we're going to so basically the formula for normalization is saying take your so your new x values. So I'm going to define that as x norm is equal to the old x values. So the old x values minus the mean of the x values, and we saw that that was just minus x dot mean, right? And then we can divide that by the range of x. So we divide all of that by x dot ptp open parentheses, and x dot ptp just means the range. Okay, and we can do this right here, but I think it's more helpful to sort of define variables because we'll be using this later as well. So I'm going to say x mean is equal to this guy right here. So this right here is going to be equal to x mean. So instead of subtracting x dot mean, I'm going to subtract x mean, which is just a variable. And I'm going to similarly define x range to be equal to x dot ptp. And I'm going to divide by x range. Okay. And so if I print x norm, I should get values between -1 and 1. Okay. So these are all values between -1 and 1. Okay. I believe there are also values between -0.5 and 0.5 as well. So, but yeah, so we normalized the x values. Now let's normalize the y values. So we'll take the y mean to be equal to y dot mean, and then we'll take the y range to be equal to y dot ptp, and then yeah, so I'm just looking up here and doing the same thing. Instead of x, I'm doing it with y. And actually, I can just copy and paste this right here. And instead of x norm, I'll do y norm. Instead of x, I'll do y. Instead of x mean, I'll do y mean. Instead of y range, for X range, I'll do Y range. So if I print Y norm, I should get this right here. Yeah, so these are all between -0.5 and 0.5. Okay. Does anybody have trouble doing that? Did everybody do that? Can you like acknowledge? Or... Okay, cool. Anybody having troubles? Okay, that gives me some confidence. So we're doing normalization to make it easier for the computer to. So as I said, when you do normalization, all the values come between -0.5 and 0.5. So normalization allows you to bring them down to very, very small numbers. And when you're doing computation with very small numbers, it's very less likely that you're gonna get overflows in your computation. So okay, did that answer your question? Okay. So yeah, so now we can remove this since we know it works, and we can just, I think, just run this and add new code. Okay. So now, so right here, let's go back here. So now we've it's between -1 and a 1, and I believe it's also between -0.5 and 0.5. So now we can define the cost function. The cost function is supposed to take in the some x values, some y values, and some theta values, and it's supposed to output the mean squared error. Okay, so we don't even need these values right now. Like we're just defining the function to take in these values, and when it takes in these values, it'll do some computation, do some things, and then it'll output the MSE. Okay. So we'll start by 1 second. So we'll define our, so in Python you would define a function by saying def, so for define, then we're going to name it cost function. Okay, and in order to tell Python to take in the values, like take in some x values, y values, and theta values, right? We're gonna basically put in x vals, y vals, and theta vals. Okay, and what this is gonna do, so we're gonna write some code over here, right? But after we write the code, if we want to use the cost function to evaluate the cost for some x values, some y values, and some theta values, we just have to do cost function, and then we do, sorry, in parentheses we give it what the x values, what the y values, and the theta values are. Okay, so the x values, we're just going to put x, and then the y values we'll put y, and then sometime in the future we'll make up a theta, and we'll put theta there. And that's how we would access the cost function. Okay. But for now, let's just make the cost function. Okay. So how would we do that? So we have to first evaluate the hypothesis. Okay. So in order to do that, we have to so if you remember the x values, they're just like 1, 2, 3, 4, 5, 6 all the way, right? And our theta values are theta 0 and theta 1 for now, right? Like we're just assuming this. We have to append a column of 1s to the x values, and that's because of the bias unit. For example, like do you remember this formula, like theta 0 plus theta 1 x, theta 1 times x, right? So this is the formula we'll be using. But instead of doing that, we can actually just do theta 0 times 1 and theta 1 times x. And this looks a lot like a dot product. And to do this, what we can do is, like, our theta values are going to be a vector, right? So theta is going to be a vector that's going to be given to us, right? This is not actual code right here. I'm just explaining this to you. So theta is a vector, and we're going to essentially multiply this theta vector by the x values. So x, we're going to multiply the x values by theta. And what that does is it takes the dot product of the first row of x, and it takes the dot product of that and theta. And what that does is it multiplies the corresponding elements in each row to the corresponding components of theta. And turns out that that is the hypothesis we're looking for, okay? And this one right here, in order to make that line up with theta 0, we have to append a column of 1s to our x values, okay? And so in order to do that, we do x vals is equal to, so there's this command called np.hstack, and then you basically put double parentheses, and then I'm just gonna copy and paste some code over here. So that right there, comma. So I want to make sure everything is all right. Yeah. So comma. Sorry, 1 second. Okay. So what this will do, right, is it will make a matrix of 1s of the size of whatever like, so basically this part right here. Okay, so to start from the beginning, what this will do is this right here is a column of 1s, and a np.hstack will just sort of append this to x vals, and it'll just put these two together, okay? And so in order to make a column of 1s, we just do np.1s, and we define the dimensions to be x vals dot shape 0. So that's the number of columns. Sorry, the number of rows in x, and then it'll make a vector of length of that same length, but instead of having actual x values, it'll just have 1. So 1, 1, 1, 1, 1, 1, 1. And concretely, right? So if I like comment out this line, and so if I just print x vals, here, let me just delete those things. Yeah. So concretely, what this will do is it'll just have 1, 1, 1, 2, 1, 3, 1, 4. So this one on the right used to be our x values, right? But we just appended a column of y value. Sorry, a column of 1s. Okay, over here. That's all we're doing over here. Okay, so I'm just gonna Control Z everything here. Yeah. So now, so does anybody have any trouble with that? Just let me know in the chat. Okay. Cool. Okay, so yeah, so hopefully you're able to follow along. And so as I said before, our hypothesis, we're just going to write hypothesis as h of x, right? hx is going to be our variable name. Hypothesis is going to be the x values, so x vals, which we defined up here, right? So like this guy right here, this guy down here, multiplied by and this is like matrix multiplication, right? Multiplied by theta values, the theta values that are given into our function. Okay, so we're gonna multiply the x values by the theta values through matrix multiplication. Okay, And so what this will do is it'll compute the hypothesis given some x values and some theta values. Okay. And then so basically we want the cost function to calculate the cost, right? So if we go back here, we want to perform the hypothesis, and so we want to subtract the hypothesis from the y values. Okay, so let's call this difference, diff, right? Difference is equal to what does it say over here? Hypothesis minus y values, right? So the difference between the hypothesis and the y values. So the hypothesis is h of x minus the y values, which are just y. Y values, as given by the input that's over here, right? Now, it's telling us to square this result. So SQ is going to be the square of our result. And this is going to be equal to diff squared. Okay, we're going to square our result. And then we're going to divide by 2m. Okay, so we're going to divide by 2m. So, we're going to say that the cost is equal to square divided by 2. So I'm going to put in parentheses divided by 2 times m. Okay, and I want this to return the cost. So return cost. And what this will do is if I say cost function and then some values of x and y and theta, if I do that, then return cost will just literally give me the number cost. Okay, so if I write cost, so if I write cost function of x, y, and some theta, right? We'll define this later. Then this right here will literally be a number, okay? And that if we compute this for np dot zeros 2 comma 1. So if our theta is 0 and then 0, then the cost function will be so let me see what's going wrong here. Oh, sorry. So we have to take the sum of the square of the values. So we have to take this sum right here, the sum of the square of the values. If you remember that sigma. So we can take the sum of these values, and that should work. If I run this again, yeah. So this will just give us the cost of 21536. Okay. So this right here is our cost function. Okay. And let me double check to see if I got everything right. It looks like everything is right. But if something is wrong, we'll come back and redo it. Okay. So we've defined the cost function over here. So does anybody have trouble doing that? Okay, sure. Okay, so we're going to really quickly just make the gradient function. Okay, the gradient function. So we're going to define the gradient function. So we've made the cost function, right? Now we're going to define the gradient function. So gradient. We're going to name this function gradient. So we can just refer to it as gradient. And this will take in these same values, okay? And then from that, it will return the new and improved theta values, okay? Okay, so what we're gonna do is first, just like last time, we're gonna compute the hypothesis. Actually, let's go back to this slide. So yeah, so we did all of this stuff. So we're gonna compute the hypothesis, first, right? So evaluate hypothesis. And then we're going to say that the new theta values, so let's see. The new theta values equals the theta values, the old theta values, minus alpha over m times the transpose of x minus the hypothesis minus y. Sorry, multiplied by the hypothesis minus y. So this is just a big formula which can be derived using some calculus. And we're just going to apply this for now. Not focus on the proof, but apply this. So just like last time, we can just use this right here to calculate the hypothesis. And now our hypothesis is stored in the variable hx. Okay. And so now it says that return theta minus alpha divided by m multiplied by. So this is a huge formula right here, right? So we're just gonna copy that down. So return, let's see, theta minus, so theta minus, we're gonna put in parentheses alpha divided by m, right? So we're gonna put double up parentheses actually. So we're gonna put alpha divided by m, okay, multiplied by the transpose of x. Okay, what is the transpose of x? Transpose of x is just x vals. Oh, sorry, I meant to take theta vals. Okay, if I said theta, that wouldn't be defined because I haven't given a name to theta yet. So theta vals minus alpha multiplied by m, sorry, divided by m, multiplied by x vals, and then the transpose of that. And to do the transpose of that, all I have to do is dot capital T. Okay? And then I would multiply that. So my formula is telling me that I have to multiply, so I have to multiply that by the hypothesis hx minus y. Okay, yeah, so it looks like it should be okay now, right? So now this should, so basically when I do gradient, if I put x comma y comma np dot zeros, np dot zeros of size 2 comma 1, this should tell us, or I have to print that actually. This should tell us the gradient, or like the new theta values after zeros, so how they should be adjusted. So we get a name error. Alpha is not defined. I feel like I defined alpha. Alpha is up there. So let's try running all. So we can restart and run all. Let's see. So, okay, 2.49. Okay. Let me see. What is the problem here? Then return theta values. Okay, so return theta values minus alpha multiplied by, or alpha divided by m, multiplied by the transpose of x vals multiplied, sorry, this right here is supposed to be matrix multiplication. So instead of doing multiplication, when we do multiplication, that's element-wise multiplication. But we have to do matrix multiplication, and that's dot. So we have to use the dot function, and this should be fixed. Yeah, so So this is telling us to change our theta values like that, okay? And that is how we would define our gradient function, okay? Um, and so as a summary, first today we just introduced the project, right? So this is basically the end of class, right? So first we introduced the project, and then we imported the data, defined the variables, defined the cost function and the gradient function, which we'll be using tomorrow for gradient descent in linear regression and polynomial regression. So go over this code again and make sure you understand every single step in the code and how it works. And yeah, so we'll be implementing linear regression and polynomial regression tomorrow. Okay? And so does anybody have any questions? If you don't have any questions, you can leave if you want. Why do we need to normalize the y values? For the same reason as we need to normalize the x values. We need to normalize both, right? Because we're doing we're doing a lot of computation on both, right? And by the way, if you're still around, I kind of sort of realized my error. And so like if you might be wondering that 404 and 10,000 are not natural numbers for the theta values. And that's correct because I put x and y. I should have put x normalized and y normalized. So that just scales down everything. And this should give, yeah, so this will give 404 and 2, okay? And so that is much better. Yeah. Does anybody have any questions? Oh, sorry. Any computation on x values? We are. Oh, y values. We're not doing computation on y values because, like, what do you mean by that? We're subtracting that from the hypothesis, right? So we're taking the difference between the hypothesis and the yeah, it's okay. You don't have to see my code, but yeah. So what we're actually, I can share my screen actually. See window. Okay. Right here. So we're doing, I think the computation we're doing with the y values is we're subtracting it from the hypothesis. Yeah. So okay. Yeah. So what is your point? You can unmute yourself if you want.
Okay, like so when I was like just looking at the course, like so we don't have to normalize the y values, I thought, because like if our input the normalization is meant to keep your x values in a small range because gradient descent is very inefficient if you have a long range of x
No.
values. But I thought the y value doesn't matter because either way we're that we're doing our computations based on the x values. So that's what I
Yeah.
thought.
So I see what you're saying, but the thing is that since we're doing hx, like we're computing, like, so this is the hypothesis, which we're computing based on the x values, and when we feed it in, we're going to be using the normalized x values. So this hypothesis is going to be a sort of normalized hypothesis, and we can't just subtract the y values because we'll be comparing like apples to oranges. We have to compare apples to apples, right? So we have to compare it to the normalized y values, otherwise it won't work.
But
So either we have to,
if we don't normalize, we'll just end up with large theta values. I don't think it'll make a difference.
large theta values,
Because like to deal with like to deal with the large y values and the small x values, I guess we'll just end up with we'll end up with pretty big theta values in order to like
yeah, but
get
if you remember what the theta values are, the theta values are like, okay, so wait, if I use just y over here, right? I get so let me see. Sorry. So I get 404 and 10,000, right? So 10,000 is your slope, and that's kind of high. Your slope is like, it's like super duper high. That's, I mean, I guess if you used x norm, and then that should be okay, I guess. But yeah, I guess it's fine either way.
Okay. Yeah, that was just my question. Okay, bye, Jay.
Bye. So do you have a question? Oh, okay, sure. Okay. Gonna end the recording now.